Hello, welcome to this tutorial. So today we are going to actually talk about sets. So basically, a set, let's define a set. Okay, let's make a definition of a set. So a set is defined as a collection of numbers or objects, all right? When you collect numbers, when you collect numbers or objects, we define that as a set, all right? So examples can be the sets of students in a class, in a specific class. Can also be the population of males in a specific town or village. Okay. Popular examples that we must have been familiar with is the set of numbers. Okay. For example, if we have a set of numbers as that's example one, we have numbers like 0, 1, 2, 3, 4. This is a set of numbers. Or we can also write another example to be the set of all vowels. You can call that V. We are all familiar with our vowel sounds. Okay, so that's a set. That's basically a set. We use the symbol this to indicate that this is an element. It's an element of. So from here we can say that A is an element of V. But we can also say that A is not an element of if this was a set of numbers n, not an element of n. Okay, when we write this and we cross it, it means it's not an element of. But when we represent a set, say A equals to this, it means this is an empty set. There is no member in that set. Okay, it contains no element. It can also be represented as A equals to. It means this set is empty. There's no members or elements inside those sets. All right. So let's actually look at some special number sets that you should be familiar with in solving problems in sets. Special number sets. Okay. So the first, we are going to create a list in which we are going to mention all the number sets that you should be familiar with. The first one is the natural or counting numbers. Okay, so this is denoted as capital letter N, and it's equal to all the sets from 1, 2, 3, 4, 5. It goes down to all the numbers that you can count. Second one you should take note is the set of all integers. Okay, this is a set of all integers and is denoted as Z, and this equals 0 plus or minus 1 plus or minus 2 plus or minus 3, and so on till as far as you can count. Okay, this symbol stands for plus or minus. It means plus 1 is in this set and minus 1 is in this set. So the third one is the set of all positive integers. So is represented as the letter Z with a plus sign on top, and it contains all the positive integers. So this contains 1, 2, 3, 4, and so on till you can count. And we also have a set of all negative integers. All right, this is denoted as this, and it contains what? It contains -1, -2, -3, down to all that you can count. The next set you should take note of is a set of all rational numbers. Okay, so those are, when we say rational numbers, we mean numbers that can be written in the form of P over Q. Okay, here P and Q are integers, and Q is not equals to 0. That means Q can never be 0. Immediately Q is 0, this expression becomes undefined. Okay, so that's the set of all rational numbers. So let's make a guess there. What will we have as members of this set? We will have something like and it's denoted as Q. Okay, we have something like 1 over 1, sorry, 1 over 2. All right, 1 over 1 is also possible, but that will be 1. So P and Q are integers. That means they are in the set of integers. So we can have 1 over 2. We can have -1 over 2 as a member of this set. We can have 1 over 3 and so on. So that's the set of rational numbers. And finally, what we should also look at is the set of all real numbers. Set of all real numbers. And it's denoted as capital R. Okay, denoted as R. So these are numbers that can be placed on the number line. It's a set of all numbers that you can find on your number line. Okay, this is your number line. Generally, we have 0. This side is a positive. This side is a negative. So -1, -2, -3, all are in this set. 0 is also in this set. 1, 2, 3 is also in this set. It's even possible to have 1.5, 2.5, because you can place them on the number lines. Okay, so that's it for some special number sets that you can actually find or you will actually make use of while solving problems in this section. Okay, so let's go into something else. I think the next thing that we should look at now is how to count elements of a set. Okay, so how do we count elements of a set? So how do we count set elements? Sorry about that. Not a mix up. So how do we count set elements? So the number of members or elements in a set is written as, let's consider a set A. So the number of elements in set A is written as n bracket open A. This tells you that you are checking the numbers of elements in set A. Okay, a set in which you can count, you can actually count all the numbers of elements in it is called a finite set. But the one you cannot count the number of elements in it is called an infinite set. Okay, so we are actually going to make some illustrations here. We are going to make some illustrations here, and we will look at some examples and see if they are finite or infinite sets. Okay, let's take the first example. Okay, given a set A equals to 2, 4, 6, 8, 10. All right. So what's the number of elements in set A? We can count it to be 1, 2, 3, 4, 5. It's 5. So this tells you that this is a finite set. Okay. Okay, how about given as this set to be equals to null? So what's the number of elements here? Is 0. Is this finite? Yes, it's a finite set. Okay. What about a set of, let's say we have 3, C equals to a set of all numbers. Is this a finite or infinite set? This is an infinite set. Reason being that you can't actually exhaustively count the set of all natural or counting numbers. It's actually from natural or counting numbers is actually a set of from 1 to down till infinity. So you can't count it. So same applies to the set of all same other examples of infinite sets as integers, positive integers, negative integers, rational numbers, and real numbers. All these sets are sets in which you cannot count their members. So these are infinite sets. Okay, so that's it for that. Let's briefly look at subset. Okay, so if we have two sets A and B, okay, if A and B are two sets, A is a subset of B if every element or member of A is also an element of B. Okay, so examples if we have set 2, 4, 6, we can say that this is a subset of another set which contains 1, 2, 3, 4, 5, 6. Okay. Now, when we are dealing with subsets, we can have a proper subset. So let's define a proper subset. A proper subset a proper subset is a set. If we have, let's say, two sets A and B, A is a proper subset of B if A is a subset of B but is not equal to B. Okay. So the symbol for a subset, symbol used. So symbol for a subset is this. Symbol for a proper subset is that. Okay. So let's explain this with more examples. We say that A is a proper subset of B if A is a subset of B but is not equal to B. All right. So for instance, let's say the set of integers and the set of rational numbers. Okay. Now we know that the set of integers comprises of, if you can recall, the set of integers comprises of 1, 2, 3, 4 down till infinity. The set of rational numbers are numbers which can be written in form of P over Q, where P and Q are what? Integers. Okay, so if you compare these two sets, you notice that it's possible to find members of Z in Q, but some members of Q, you might not find them in Z. Okay, so what does that tell you? It tells us that the set Z is a proper subset of Q, since any integer Z can be in Q, but some members of Q might not be in Z. Okay, so that's it for subset. And we also take a look at union and intersection subsets. Okay, union and intersection of sets. Let's, so if A and B are two sets, if if A and B are two sets, A intersection B, this is a sign for intersection, simply means that we are looking at the intersection of A and B, and it contains all elements which are contains elements which are in both A and B. Okay. The next one is the union of the set, and it contains all. A union B means this is a symbol for union. A union B means it contains the set that will be formed by A union B will be elements which are in A or B. Okay. So to actually explain this fact well, let's take example. So if A equals to 1, 3, and 4, and B equals to 2, 3, 5. Okay. So the intersection of A and B will produce a new set. You look at elements which are in both A and B. 1 is not in B. 3. Okay, let me make this easier here. Okay. 3 is in both A and B, so we take 3. 4 is not in both A and B, so A intersection B is that. And if we are looking for, let's look at the union, A union B. So there are elements of set which are in both A and B. Okay, so we have 1, we have 2, we have 3, we have 4, and we have 5. These are elements that are both in A and B. Okay, the set of integers is made up of the set of negative integers, 0, and the set of positive integer. All right, so we can actually write another example that we can illustrate this is that we can say the set of integer is made up of negative integers and a union of 0, because it also contains 0, and a union of what? Positive integers. Okay, so that's where we will stop today as regards to an introduction to sets. And when we come next time, we will talk more on these joints of sets and see how we can actually okay, before we go, let's just wrap it up with, actually let's look at these joints of sets so that we can be done with that. So let's look at this concept of these joints of sets. So two sets are disjoint or mutually exclusive if they have no elements in common. If A and B do not have any elements in common, say A equals to 2, 4, 6, and B equals to 3, 7, 9. Okay, they have no members in common. So if you check for A intersection B, you form a null set. You form a null set. So they say that they are disjoint or mutually exclusive. Correct? Okay. So all right, let's try some examples here. Given two sets, M equals to 2, 3, 5, 7, 8, 9. and n equals to 3, 4, 6, 9, 10. Okay. Is 4 a member of M? That's, we check M. That's false. Okay, it's not. What of M intersection N? Okay, we say M intersection N is members that are common to both sets. We can see that 3 is common. What else is common? You can also see that 9 is common. Okay. So you can try on your own to look for the union of M and N. Okay. You can pause this video and look for and try solving the union of M and N. Okay. So if you got this 2, 3, 4, 5, 6, 7, 8, 9, 10. You are in order, okay? So that's basically what we will cover today about sets. You can try these exercises on your own. Try to write using sets notation. 6 is not an element of set G. Alright, you can write it down here as a comment, or you can join our class in which we will respond to your answers on the WhatsApp platform. Alright, thank you. See you in the next tutorials. Bye for now.